Next one is preparation methods. First we will discuss preparations of alkyl halides, and after then we will go for the preparation methods for aryl halides. Clear? And first one, preparation of alkyl halides. First one is from alcohols. Clear? Alkyl halides are prepared from the alcohols by the treatment of halogen acids or phosphorus halides or thionyl chloride. Clear? Alkyl halides are prepared from alcohols by treatment with which one here? Halogen acids or another one is phosphorus halides and also thionyl chloride. Okay. So first one we will discuss, and here treatment with halogen acids. Treatment with which one here? Halogen acids. And after that we will go for the phosphorus acids. Treatment with halogen acid. First one with halogen acids. Clear? So halogen acids means you already know. What are the halogen acids? Hi, HF, HCl, HBr, HI. These are the halogen acids. Commonly we will denote this one with the HX, hydrogen halides, and those we will call it as a halogen acids. Clear? First what we will do? We will treat this alcohol, because we are preparing these alkyl halides from which one? Alcohol. So that's why you know the general formula of alcohol is ROH. So we will treat with the halogen acids. What is the general formula for halogen acids? HX. Then you will get the compound is R, remove this water, OH from here and H from the HX. Then you will get the compound is RX plus what you will get here? H2. RX plus H2. So this is what it is, alcohol, this is what it is, alcohol, and this is what it is, alkyl halide, or you can simply say haloalkane. And prepared from where? Prepared from hydrogen acids, or halogen acids, not hydrogen acids, halogen acid. Clear? So this is general reaction of preparation of alkyl halide from alcohol by the treatment of halogen acid. Now, what is the reactivity? In this reaction, what is the reactivity of alcohol and what is the reactivity of halogen acids? First one is reactivity. Reactivity of ROH. What is the reactivity of ROH is, and tertiary alcohols are more reactive compared to the secondary alcohols than what it is primary alcohols. Means what does it mean? Means tertiary alcohols will react very fast with the halogen acid compared to the secondary alcohols and primary alcohols. And what is the reactivity of HX? What is the reactivity of HX? So HX reactivity means HI and here HBr and then HCl, and next one is HF. Why it is more reactive HI? Because the bond between the hydrogen and iodine means iodine atom is longest. If bond length is long and that bond strength will be less, so that's why the bond can easily break, so it involved in the reaction very fast. Clear? So that's why, and here HI will be more reactive compared to the other halogen acids. Clear? So this is the reactivity of alcohols and reactivity of hydrogen, you can say halogen acids. Clear? So now, and first one I have mentioned here, reactivity order of the halogen acids. First HCl reaction with the alcohol. Clear? And I will take simple example here. Suppose if I take CH3 and CH2OH. Clear? This is which alcohol here? Primary alcohol. So when primary alcohol react with HCl, but you know HCl is less reactive, and you know primary alcohols also less reactive. I have given already reactivity order. Both are less reactive, so that's why we need here catalyst. What the catalyst we have used here? Zinc chloride. Then if this reaction means if you use the catalyst and increases the rate of reaction, then what is the reaction here? Remove here HO2O and you will get the compound is CH3CH2, and here as Cl, I will take Cl here and H2. This is clear. If I take the secondary alcohol means, shall I take, this is secondary alcohol because you know OH attached carbon is attached to 2 carbons, so it is a secondary alcohol, and treated this one with the HCl in the presence of ZnCl2. Yeah, then same reaction. What the reaction here? Remove water molecule, then you will get the CH3 and secondary alkyl halide plus what it is H2. Then if I take the tertiary means you already know CH3 and CH3OH. You know it is a tertiary because this carbon is attached to 3 carbons and HCl. For this reaction, we need not to use here catalyst, that is zinc chloride. Why? Because you know these tertiary alcohols are more reactive, so that's why these involved in the reaction very fast, so not required here catalyst, that is zinc chloride, and you will get the compound is CH3 and here tertiary alkyl halide and Cl plus what it is H2. And very important here, and the HCl 1:1 ratio of HCl plus ZnCl2, anhydrous ZnCl2, this we will called as mixture called as Lucas reagent. Very important. And this Lucas reagent is used to distinguish tertiary, secondary, primary alcohols. It is used to distinguish primary, secondary and tertiary alcohols. How it will be used to distinguish the primary, secondary and tertiary alcohols? Clear? So what is this one? 1:1 ratio of concentrate HCl and anhydrous ZnCl2 is called Lucas reagent, which is used to distinguish the primary, secondary and tertiary alcohols. You know, first one what it is? Primary alcohol. And I will take here simple, this is one beaker. In this beaker I have taken alcohol. Take the alcohol here and pass HCl gas. You know alcohol and HCl both are miscible each other. Now when the reaction starts, then which one will be formed here? Alkyl halides. Alkyl halides are, you know, and it is less soluble in this reaction mixture. Less soluble means what? You will get like a turbidity. You will get like a, what it is? Turbidity. Turbidity means, simple example, take the water. Water, you know, clear water. Water, if you take pure water and it is very transparent, very clear. And if you add some milk, then you know that it is looks like something that means you can see you like a turbidity, like a precipitate, small precipitate, like that is we will call as a turbidity. It is not precipitate, it is both are not miscible each other. Then what you will get here? Turbidity. Okay, so if you take and primary alcohols, you know, less reactive, so that's why this turbidity means the formation of this alkyl halide, and to formation of this alkyl halide takes much time, means, and you will get the turbidity within, means you will get the turbidity 30 minutes to 1 hour with the primary alcohols, and you will get the turbidity within 30 minutes to 1 hour. But if you take the secondary alcohol, you know that secondary alcohols are somewhat reactive than the primary alcohols, so that's why the turbidity will get within the 5 minutes. Within the which one? 5 minutes. Now, if take the tertiary alcohols, you know tertiary alcohols are very reactive. So that's why you will get the turbidity within the 1 minute. Means, and we can easily distinguish which one is the primary, which one is the secondary, and which one is the tertiary. Just take the beaker, add the alcohol, and pass the HCl gas, and see and observe here turbidity. If the turbidity forms in 30 minutes to 1 hour, then the alcohol is a primary alcohol, and within 5 minutes turbidity, you get the turbidity, then it is a secondary alcohol. Within the 1 minute, then that alcohol is a tertiary alcohol. Clear? So this is, but you know these two reaction means reaction with the primary alcohols, secondary alcohols with the concentrate HCl, ZnCl2, and this reaction or this method we can call it as Gru's method. What we will call this is Gru's method. Clear? When this is not, why? Because we have not used here ZnCl2. The primary alcohols and secondary alcohols reaction with the Lucas reagent. What is the Lucas reagent? HCl and ZnCl2, and that reaction we will call as a, and Gru's reaction, or that method we will call as a Gru's method. Clear? So this is about the reaction with the HCl. Reaction with the what it is? HCl. So next one is with alkyl chlorides, how we prepare, we have already discussed. Now how to prepare the alkyl bromides. Clear? So same with from the alcohols. I will take here alcohol ROH. Clear? Or I will take the, and one example, I will take CH3 and CH2. This we will call as ethanol and ethanol, and it is reacted with HBr directly. Clear? Then what we will get here, and H and OH will be removed, and CH3 and Br should be added here. Then you will get the compound is CH3 CH2 Br plus what you will get here, H2O. Yeah? And this is how to prepare the alkyl bromides from the alcohol. Treated with the which one? HBr. Or another method is there. And CH3 and CH2OH, and treat this one with the sodium bromide in presence of little H2SO4. Clear? Small amount of the H2SO4. Then what the compound you will get? Br will be, and OH will be replaced by Br, and you will get the compound is CH3 and CH2 Br. Clear? Plus what you will get here? H2O, and another one is NaHSO4 plus what you will get here? H2O. Simple. OH and H remove here, what as a water, and after then here bromine is added here, and you know in one hydrogen and OH is removed as a H2O, and here Na will be added, so that's why NaHSO4. This is how to prepare the alkyl bromides from the alcohol. In the same way, alkyl iodides also can be prepared. How it can be prepared? CH3 and CH2OH, same. Treated this one with the HI. Then what the compound you will get? Same iodides. You will get the compound is CH3, CH2 and I plus H2O. Another method is there. And here CH3, CH2OH, and treat this one with the potassium iodide in presence of H3PO4, phosphoric acid. Same, what the compound you will get here? One hydrogen here, OH will be removed as a H2O, and that one H is removed and K will be added here. Then you will get the KH2PO4 plus what is left here, and CH3, CH2I. Clear? And here, why I have used here H3PO4? Previous what I used here? H2SO4. Can I use H2SO4 here? No, we cannot use. Why? Because H2SO4 is a oxidizing agent, so that's why it oxidizes iodide. What is there in the Ki? You know Ki is there. Ki means what? K plus and I minus. This iodide will be oxidized to iodine in presence of H2SO4. If it is iodide is converted into iodine, then there will be no iodide. If there is no iodide, there is no reaction with the say alcohol. So that's why OH will not be replaced by, and here I minus, so that's why, and we cannot use it here H2SO4. If you use H2SO4 and iodide will be consumed here, so that's why this reaction will not take place. So H3PO4 is not an oxidizing agent, so that's why we have to use it here H3PO4, but we should not use H2SO4.